Got it. Okay. Thank you. So my name is Andre Tunk. I run a service called bgpmon.net, where we look at all kinds of interesting BGP events, origin AS changes, hijacks, outages, stuff like that. So in this presentation, we're going to look at some of the recent events that we've seen and try to see if they are in fact malicious or just incidents, accidents, stuff like that. So we're going to look at a few events. The first one is hijacking for monetary gain, and we'll look at some of the Bitcoin stuff there. Using BGP to apply censorship, IP squatting by spammers, how BGP can be used as a DDoS vector, and a few other ones. So let's start with the first one. So this is supposedly the largest Bitcoin farm in the United States, somewhere in Washington State. There are literally thousands and thousands of boards collecting Bitcoins. So there are nowadays, dedicated data centers with dedicated hardware just collecting Bitcoin, just to show you that there's a lot of money to be made with that. Sometimes that goes wrong. This is a similar large Bitcoin farm in Thailand that unfortunately went up in flames. Supposedly they weren't insured. But it does show that a lot of people do invest heavily in buying hardware, set up data centers and stuff like that. But most of us, or if you're interested in Bitcoin mining, probably don't have that. And instead, what we do is we just use cloud resources, right? Use Amazon, OVH, DigitalOcean, whatever you're used to. So that's sort of where this story starts. So the way Bitcoin works is when a Bitcoin miner comes online, it registers itself with a Bitcoin sort of a group server. And they have a protocol. It's just a bunch of JSON messages that go back and forth, where you get jobs, you get your rewards from, but the server can also redirect you to another group server for load balancing purposes. So if you do not have thousands of dollars worth of hardware or willing to spend it on cloud resources, if you can somehow get access to this pool server, and you get all the sort of jobs and you talk to all these servers, then you have potentially access to a lot of computing resources. And that's exactly what happened with this attack. So this was originally published and detected by the guys at Dell SecureWorks, and they have a really good report explaining how this worked. But what happened was some of these pool servers run in OVH and DigitalOcean, Amazon, all the typical cloud computing resources. And what happened is that the attacker, which either was a Canadian ISP or he had access at a router for this Canadian ISP, announced more specific /24s for several of these Amazon, DigitalOcean, etc. blocks. Then set up a server listening to the IP addresses that supposedly were these pool servers. Only did it for a few minutes, but it was enough to get the Bitcoin miners to talk to them. He then initiated a redirect saying, okay, I'm going to load balance you to another server, to a server that he controlled. And now the Bitcoin miners are sort of sticky to that server. They collected all these, or they were generating Bitcoins or finding the magic algorithm, whatever, how it works exactly. But they were never getting any rewards for it. Instead, he was keeping the rewards. So it's interesting that the hijacks are fairly short in duration, but because he was able to redirect them to another server, the miners would use that server for a long time. There were a bunch of providers that were affected by this. Obviously, a very advanced and targeted attack, but also interesting because it wasn't just like, I'm going to originate this new /24 and set up a server. He was also trying to actively hide himself. It was using, I guess, a technique called ASBOF spoofing. This is really just ASBOF prepending. And at times you could actually see, if you looked at the rightmost AS in the ASBOF, which is normally the origin AS, you could actually sometimes see like he was actually putting in Amazon or just a range of ASNs that were totally unrelated. But if you looked a little bit closer, you could see that there was always one ASN that was in common, which was this Canadian AS. So the guys at Dell SecureWorks estimate that about 83,000 worth of Bitcoins were stolen this way. Looking at the BGP data, we can see that the scope was still a bit limited to only peers at the Toronto Internet Exchange, TORX, because we only saw the announcements via peers of this network on the TORX. So that means that it's a fairly large exchange. Still lots of people that were affected by this. If we look at the numbers, we saw about 51 prefixes and 19 ASNs. And again, those ASNs are all the ones that you expect: AWS, OVH, DigitalOcean, eSwap, etc. So definitely, I think this definitely is targeted, interesting. Even though obviously he was typically only interested in 1 or 2 blocks out of that /24. These blocks are typically announced as larger blocks, so especially Amazon announces like large chunks, like /18s, 15s. If you have a prefix that happened to be in that same /24, that would have been affected as well. So there was some collateral damage as well. Another thing, so Jeff just talked about how DNS can be used to bypass censorship. So this is a perfect example of that. In the spring of last year, the Turkish president ordered, there were elections, and there was stuff on YouTube and Twitter that he didn't want, I guess, the people in Turkey to see. So he ordered that to be blocked. And there's different ways of doing that, but in this case, they decided to do it on the DNS level. Pretty quickly, pictures like this showed up in the news, and people had found a way around the censorship. So you saw 8888 being spray painted on walls, bus stops, and stuff like that. People were now all of a sudden able to get around this censorship. So everybody happy, except for the government. At that point, they ordered to null route the addresses of these popular open or DNS resolvers. Addresses that were being null routed were these 888, Google's OpenDNS, level 3 open resolvers were all affected by this. But the initial null route was actually very short in duration, because the problem was they broke the whole internet for everyone in Turkey, or at least everyone who uses this. Because the internet or the DNS was broken, it's like the internet's broken. But obviously, so they undid that, and but a day later they did it again. They inserted a new route or /32 routes for these popular DNS services, had now set up a DNS server with those addresses, and were actively intercepting and rewriting these requests. So at that point, we could see, for example, at OpenDNS, significantly, or almost 100% drop in traffic from Turkey for 1 or 2 days. Scarily enough, the service still seemed to be working for the users in Turkey. But in fact, talking to Google or OpenDNS, they were in fact talking to a server controlled by the Turkish government. So this is an example of the Turk Telecom looking glass at that point. So we requested the route for 8888, and what you can see, or what you would expect, is a /24 with Google's origin ASN. But in fact, what you're seeing is a /32, and the AS bus empty. It's an internal route, so they are originating this route and now redirecting it to a server they control. And similar routes were visible for OpenDNS and level 3. So if you then did a dig from within Turkey, we used RIPE Atlas to initiate this measurement. So in orange, you can see a DNS lookup for youtube.com using 888 from within Turkey. And this is the address that you got back, the one in orange, which is a server controlled by Turk Telecom. And interestingly, Twitter was pointing to the same address at that as well. And in green is something you would expect to see. So this is another example how we can use, or how people are using censorship or BGP to apply censorship, set up a new server that they control, and do with it, do whatever you want, basically. So one other example is IP squatting. So I think it's long been known and assumed that spammers use IP squatting to basically send spam. So their biggest problem is obviously we need clean addresses that did not end up on a blacklist yet. Once you start sending spam, it will take a few hours and it's there, and then you can't do it anymore, or at least you're not as effective. So the theory is that you use unannounced address space, and even though we're running out of address space or IPv4 address space, there's still large chunks of the IPv4 space that are unused. If you can just find those and announce them, then you send spam from those. You're virtually untraceable, and you can just rinse and repeat that over and over again. So we got some emails from people who use our service and saying, hey, I've noticed that my address has been announced, and now I'm on some spam called blacklist. After the second email, we started to look into this a little bit closer with these users and found some interesting patterns. So one of the ways you can detect these operations is to just run some top 10 or top 20 lists of people who originate new prefixes every single day. So, depending on the size of the network you run, if you're a small provider, you probably originate, I don't know, 1 or 2 prefixes. If you're a medium provider, you probably originate 1 to 2 new prefixes a month. If you're large, you do a handful a day. But if you do originate a dozen or so new prefixes each day, like these guys are doing, that's very suspicious. So you can easily create that list and find that. So we did that, created a top 20 list and just eyeball it and say, okay, it's level 3 NTT, bunch of DDoS mitigation providers that easily stand out. But whatever remained were sort of, providers I'd never really heard of. And so it's kind of weird today we're announcing new space every single day over and over. So we started visualizing some of that. And this is a screenshot from a tool called RipeStat, where you can just provide it with an ASN, and it shows you the lifetime of each of the prefixes over time. So each green line is the lifetime of a prefix. And you can see that, this operation, and there's quite a few of these, they basically announce new space for a few hours every day in batches of 8 prefixes, stop announcing it, and immediately start a new batch of prefixes. So very interesting. So we started to reach out to the upstream providers of these guys and say, hey, do you know what's going on? And it happened that we knew quite a few of these guys, so we worked with them. Some of you guys are in the room here. And first of all, we said, do you know what's going on? And one of the interesting things that we heard initially was, you know what, this customer is listed as a DDoS mitigation provider in our files, and that's the reason why they're announcing new space all the time. I was like, okay, that's interesting, because this space is not used by anyone, so I'm not sure who you're protecting. So we went on from there, and we're pretty quickly able to determine that, based on NetFlow data and stuff like that, that this, it was indeed all spam, or at least all email. It's so much, basically 100% SMTP traffic, so much that it was almost suspicious. Like, there's no control traffic. There was basically no DNS traffic, no SSH traffic, or any of the other traffic that you would expect. So, I mean, it's a different discussion, but we think that there might be just another control channel into this operation. But the second question quickly became, why are you not filtering these guys? It seems to me that you're just letting them announce new prefixes at will. I know you're reputable. What's going on here? Did you just forget to apply the filters or something? And he said, no, we use strict filtering, and our filters are based on route objects. And indeed, it turns out that these guys had added route objects for each of the prefixes that they announced. Which highlights an interesting case, because the provider in question was doing what I guess most of us would expect them to do. There were route objects, they were generating filters every day, and still this got through. So the interesting thing is, so with RDB and some of the other databases, you can just add any route object you want for any prefix you want. So people can add prefixes or route objects for this, for Google, for DNS root name servers, for your prefixes, for my prefixes. It's scary stuff, right? Once it's in there, they will just, most of the providers will generate filters and you can announce it. Pretty scary. It's not like that with all databases, like Ripe and APNIC. There is some form of check if you actually own the block, but something like RDB, which is definitely one of the more popular providers, allow you to register in. It's not all bad though, because with this data, we are able to then look at what else is this AS doing? So we started to run a report for what other route objects are in there, and we saw thousands of route objects for this origin ASN, which by the way is registered to someone in Argentina, but that's also squatted. That AS hadn't been used in years. They probably just registered the email address and got access to it. But yeah, indeed, we were able to verify that there were route objects for announcements that were seen in the past and were used to spam. Many of those prefixes were now on spam lists. But it also gave us a looking glass into the future, because some of these things weren't announced yet and were indeed being announced over the next few days. And the other thing was, we can take a look at the maintainer object, and we find all kinds of interesting things. But one of the things was what we previously believed to be separate operations, as in like different ASNs and upstream ASNs, were actually one and the same operation, we believe, because they all shared the same maintainer. So that maintainer had created route objects for other ASNs and prefixes as well. Basically done the exact same thing, but just share the risk a little bit, like this upstream provider is going to shut me down and at least have the other one still. So we worked with the providers. Many of them did what they had to do, reached out to RDB, who apparently removed the account. A few days later, all those route objects were gone. So this is another interesting case where spammers use this a lot, because there are literally thousands and thousands of these things going on, and still are going on. This is another interesting picture for another one of the other ASNs. This is over December and January, and you can see two interesting gaps here, just over Christmas and New Year's, where apparently spamming doesn't have to happen, and they just take some vacation. So talking about spamming, this is in 2013, it's a little bit longer ago, but I think most of you remember the DDoS that almost broke the internet, or not. But either way, Spamhaus, one of the fighters of spam, was being attacked. They moved to Cloudflare and got 300 gigs of data, and lots of stuff broke. But at the same time, there was another attack vector. Someone, the same person who supposedly initiated the DDoS, also started to announce a /32 for one of the Spamhaus RBL servers. So an RBL server is basically a DNS server, and you say, is this IP address reputable or not? And it will return a positive or negative return. So what this guy had done is insert that route, actually set up a server, and was replying to DNS queries, and was actually saying, for every question, it's like, is this IP address spam or a spammer or a bad reputation? We say yes, 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 yes. So basically, everything was marked as spam now. So the amount of spam that, or the amount of email that was marked as spam during this period went up significantly, basically rendering the Spamhaus servers unusable for people, and they had to shut this down. So this was primarily seen, this particular announcement was seen over the Amsterdam Internet Exchange at that time. Which brings up another interesting point. If you remember the Bitcoin thing, that was also seen just on an IX on the Toronto Internet Exchange. So it's almost like, our providers tend to do a fairly good job of filtering. Obviously not perfect, but there are methods in place, and we've talked about that for a long time. But on internet exchanges, most of us don't. We just use max prefix filters, and if you announce 25 prefixes today, I probably allow you to do 30 or 40 or something like that. And if you sneak in one or two more, that nobody will really notice, which is why some of these things are more effective over internet exchanges. So another example here. So this internet in Syria has been talked about a lot. We've written about it, tweeted about it. So primarily around outages, right? So there's one major telecom provider in Syria, SDE. They've been offline every now and then. But as of December and again in January, we saw two unique events where they misoriginated or hijacked, whatever term you prefer, close to 1,500 prefixes, affecting about 300 autonomous systems. Typically for a few minutes. Obviously, I have no idea if this was intentional or not. I can just look at the data. But either way, I think it doesn't really matter because traffic was affected. Traffic was being redirected, and this is a visualization for one of the YouTube prefixes. The big red dot is Syrian Telecom. You can see that all the announcements were propagated through, in this case, Telecom Italia. SDE has multiple upstream providers, but this was only seen through Telecom Italia and then propagated to the guys like NTT, Hurricane Electric, All these guys together have a fairly large customer count. So it's likely that many of these guys would have been redirected towards Syria. Prefixes that were affected included level 3, DoD, YouTube in this case. So there would have been quite a volume of traffic, and as a result, the links would probably have been adjusted. So whether this was intentional or not, could argue, but definitely it would have affected connectivity for these prefixes for a significant amount of users. And this is another, sort of similar case where route leaks. So I guess route leaks, the term's been used for different things, but what I mean in this case is you have two providers like level 3, NTT, and a smaller guy in the middle, and the small guy basically relays the routes that it learns from level 3 out to NTT, vice versa. Some of that is filtered, but sometimes we see stuff filtering through, and typically this has to do with people with outdated prefix filters where maybe Cloudflare or AWS in this case used to be a customer, and they would just match on the prefix and it gets through. So this caused a significant outage for Cloudflare in October. AWS was affected by the same incident, and it actually happened again just like a month later with a provider in the Philippines, where you can clearly see lots of people changing paths to that smaller provider. If you think about the amount of traffic that guys like AWS and Cloudflare do, obviously depending on the prefixes that were affected, it's easily a few dozen gigs, maybe 100 gig or so, depending on the prefixes. But probably more than these smaller providers can handle, and that's exactly what happened in October. Traffic gets rerouted to, in this case, Colombia or Argentina, and that's where there's a bottleneck, and again, there's an outage. These things happen quite a bit. They've happened for a while. We all know about this, but they do cause significant outages. Most of these are not intentional or malicious, but again, the effects are very similar. So we looked at a few examples. Some of them definitely look suspicious. You talked about the Bitcoin one, the Turkey one, spammers, spam house incident. But the far majority ones are probably just incidents and fat-fingered. That doesn't mean that it doesn't matter, because it probably still causes an outage or some kind of an event for your network. When we look at what are the causes for some of the incidents that think are accidents, it's typically route redistribution, BGP into OSPF or ICS, and then out to BGP again. Traffic optimizers tend to be, strangely enough, a lot of times involved somehow. So traffic optimizers are devices like Noctian and Internet. They figure out what are your popular destinations, and then they do measurements, and they figure, oh, if you wanted to go to YouTube, your provider here is better than the other. Sometimes they create new announcements. So let's say that, I don't know, there's a /16, and they're gonna optimize that. What they do is they make up a new /2 new /17s, insert that, and that's all fine as long as it stays within your own network, but then it leaks out, and people basically leak out this bad announcement, similar as what happened with Pakistan and YouTube, where they basically exported their censorship. Another interesting one is if you look at the ASNs that are involved in what appears to be hijacking, you see a suspiciously high number in the lower AS numbers. So AS2, 3, and 4, 5 seem to do lots of hijacking, which seems odd. But in fact, it's not really a hijack. What are people really trying to do is ASPAF prepending. So they type in, I want to prepend twice, or 3, or 4. What you don't realize is what they actually type in is the ASPAF. So what you then typically see is the next hop is the actual ASN. So it's not a hijack, but it's definitely an interesting observation in terms of who's involved in these kinds of things. Anyways, that was a quick summary of what is going on. Lots of non-suspicious events, but definitely some interesting ones that I think are worth looking at. That's it. I think we have 5 minutes for questions, if there are any.
Randy Bush, IJ. Good talk, Andre. Thank you. Two things. One is a comment, which is you can put anything in the right database. It does have more protection, so does APNIX, but it's got plenty of garbage. It is not golden. Two is What interests me more is the path attacks. We have the one at AT&T in 2007. We have the well-known one by Tony and Alex at Black Hat in, what was it, 2008. But seeing it in Amazon, and the problem with them is a well-done path attack is very localized, which is for financial gain ideal. Everybody in Cleveland sees the Cleveland Bank is in my back pocket. Much harder to detect, much harder to see. What kind of measurement infrastructure, if we wanted over the next couple of years, to see if these were occurring? You know, the RIPE Atlas probes are usually too far from the routers. Is there anything we can do to try and see, you know, the misannouncements, they're happening every day, we're used to them, we know what to do about them, someday we'll do something. The path attacks are sneaky, nasty, and really hard to detect.
Yeah, that's a good question. I don't think I have a real solution, but I'll throw out some of the things. So first of all, yeah, just looking at the origin AS is very dumb, and you'll catch a lot of the noise. Looking at all the AS paths in sequence is, just in terms of compute, very expensive, but it's something you can do if you just filter out some of the select ones. What we've been doing is actually focusing on the new, more specific prefixes, and that's what we've seen with, I guess, the stealing the internet thing at DEF CON. They used the more specific. The one we saw with the Bitcoin ones, more specifics. So that helps us sort of filter out the noise, and every time there's a new, more specific, we do actually do a full path analysis and see, does this make sense? Do these origin ASNs really buy from each other? Are they really connected with each other? And if not, they are marked as suspicious. And at that point, we could do something with the RIPE Atlas project, launch trace routes and stuff like that. But it's very hard to just look at the AS path and see if that's normal, because there's no definition of what is normal.
Sandy Murphy, Parsons. Wanted to talk about the RADB problem that you noticed. There is a security model for IRR systems, but it all derives from knowing who has the rights to speak for a prefix. RIPE and APNIC are in a position to know that. So in their case, they've implemented the security model. All the other IRRs that aren't associated with an RIR, and thank you so much for the person who got that confusing set of acronyms involved. They're not in a position to know authoritatively who has the rights to speak for a prefix. So they really can't do a rigorous trust model. There are RIRs that had IRRs that employed the security model, but their members asked them to turn that off because they like doing proxy registration for their customers. And there's no provision for securely doing that sort of thing. I also heard recently of someone who likes to track spammers and their activities, that they're beginning to be clever and devious about where they inject these announcements of unused space to places that aren't going to see the update traffic collected by RIS and route views and the other collector systems. So they're invisible to those systems that are trying to do anomaly detection. So, you know, they're smart and they're just keeping, we're having to keep track of where they're going all the time. It's an arms race.
Yep.
So, thank you.
Yep. So I guess back to the spammers, that's actually interesting, because I guess if you try to localize it, then, you know, spamming won't work as well. Unless you want to specifically target certain providers, this is when it will work, and there are definitely some rumors going around that certain providers are targeted more than others. When we did some trace routes to some of the IP addresses that were being announced, just briefly, the trace route would just die, and then you would see many, many stars, and so they were definitely trying to hide. We were just basically trying to map the infrastructure. And then all of a sudden, like after like 5, 6 timeouts or whatever, we saw another IP. The RTT had increased significantly, and it mapped to a provider somewhere in Chicago. So these two separate operations that we thought to believe separate, we later on mapped them to probably LA. So they were both buying out of LA. But then there seems to be some kind of overlay network or something. That's what I think it works. There's an overlay network. You just have a simple, I don't know, data center somewhere. Have GRE tunnels or something going to whatever exit points where they can buy their transit from. And so if you do some traces, I think it was a mistake because it only worked once or twice. But it was interesting that all of a sudden something else with a much higher RTT in Chicago popped up from some obscure provider I'd never heard of. Okay. Thank you.